Hello friends, this video on aldehyde ketones carboxylic acid part 30 is brought to you by examfear.com. No more fear from exam. Now we'll talk about the acidity of carboxylic acid. See, as the name suggests carboxylic acid, it clearly means it is acidic, right? And it has been seen that if you take carboxylic acid and if you react with, let's suppose, sodium, you get hydrogen gas. It clearly says it is acidic. Also, if you take carboxylic acid and you react with weak base, you will see a reaction happening, acid-base reaction. For example, I have a carboxylic acid react with sodium. This gives RCOO minus Na plus and H2. This is what the reaction is. Or let's suppose my carboxylic acid reacts with a weak base NaSO3, you see still reaction happening. Plus H2 and carbon dioxide will come out. So if you compare, this is my reactant and this is my product. It's seen that this is more stable. The product is more stable by resonance. If you see RCO minus, you have one more resulting structure. It goes in this fashion. This becomes this. So it is resonance stabilized. So the product is resonance stabilized. That means the product is more stable. The reaction will move in the forward direction. That means RCOH is reactive and it is acid. It is acidic. Correct. So the equilibrium reaction, if you want, will be like this. RCOH gives RCOO minus and H plus. Correct. And this is stable. So this is the equilibrium reaction. So it is giving H plus ions. So if you see K equilibrium or K acid dissociation constant will be what? Concentration of this RCO minus and concentration of H plus and concentration of H plus by concentration of RCOH. But since this is the formula. So the industry standard to find the acidity is pKa, that is something but the minus log of Ka. So if you see this, pK is nothing but minus log of Ka. This is the industry standard to find the acidity. And the strongest organic acid is nothing but trifluoroacetic acid, and this has pK of 0.23. Correct. So if you compare this with, let's suppose, HCl, it has a pK of -7. So -7 is maximum acidic and +7 is max basic, I can say. So this is the range. So if you see benzoic acid, it has pKa of 4.19 and acetic acid has pKa of 4.76, like that. But the strongest acid is trifluoroacetic acid. It has the pKa of 0.23. HCl is the strongest acid, and for that is the inorganic acid. It has a pKa of -7. For HCl it is -7. So with that you can make out, even if we call it acid, but they are not very strong acid. Correct. So the trend is actually, or not +7, 15 plus actually. So the trend is, if it is less than 1, it is generally mineral acid. For example, HCl. I'll do it in the next slide. So the trend is, I have strong acid, that is generally a mineral acid, and then I have moderate acid, and then I have weak acid, and then I have extremely weak acid. So for strong acid, normally the pKa value which we have is less than 1, and they are generally mineral acid. For example, HCl, they are generally mineral acid. The moderate acids between 1 and 5, weak acids 5 and 15, and extremely weak is more than 15. That is the range, right? And if you see, my carboxylic acid is in this range. It's a moderate acid, right? So you know that carboxylic acids are weaker than mineral acid, but they are stronger than alcohol. This alcohol and phenol, if you see, they lie in this range. Weak acid. So carboxylic acids are the moderate acid. They are weaker than the mineral acid, for example, HCl, right? But they are stronger than alcohols and phenols. So let's compare alcohol and phenols. So if you see the acidity, my carboxylic acid is most acidic if you compare alcohols, phenols and carboxylic acid, and then comes phenols, and then come alcohols. This is why, because see this RCOH, if you see, gives RCO minus NH plus, and this is stable by resonance, correct? So if this is stable, the reaction will move in the forward direction, and this is nothing but an acidic reaction. So it will give more H plus ions and it will be more acidic. Also, if you see, the negative charge is on the oxygen, right? That also implies it is good, because oxygen is an electronegative element. It is happy to take oxygen, it is happy to take negative charge. So that is also an advantage, right? But if you take first of the phenol OH, so it will give O minus and H plus. And if you draw the resonating structure of O minus, let me draw it for you. O minus is 1. Let me break this bond. This bond let me break in this fashion. So it becomes double bond O, and minus charge comes here. You draw more resonating structure. This bond breaks in this fashion. You get double bond O here with the negative charge. You will break. If you don't understand what I'm doing, please watch my previous videos where we explain these concepts. If you see here, these are the resonating structure I'm getting. But out of these, the negative charge is on the carbon. This is carbon. This is carbon, right? So carbon is the electropositive element. It doesn't like, it is not that electronegative element, I can say, yeah. It's not a negative element. So the negative charge on carbon, we can ignore this resonance structure. So that means it is only one resonating structure. Correct? So this has 2. If you want, I can draw it for you, RCO minus. This is 1. And the other time, negative charge comes on this carbon. So it has 2 resonating structure. It has 1 which is we want. And if you take alcohol, there is no resonance. Correct? So with this, if you see, this is slightly negative, slightly positive. So with this is acidic, but there is no resonance. So if we compare these two, carboxylic acid has 2 resonating structure. Phenol has 1 which is valid resonating structure, and alcohol doesn't have any resonating structure. So with this, we can conclude that carboxylic acid is more acidic than phenol, and phenol is more acidic than alcohol. Now we'll discuss the effect of substituents on acidity. So in this case, the electron withdrawing, for example, I'll just first write RCOH. Now let's discuss the effect of substituents on the carboxylic group. What I'm saying is you have RCOO minus or RCOH. What is the effect of this? If it is nitro group, or if it's a alkyl group, it is a phenyl, it is a chlorine, what impact it makes? So clearly you can see that, see if this has to be more stable, right? For RCOOH, to break into RCO minus and H plus. More stable it has to be. Correct. So now if you see the resonating structure of this is 1 and this is 1. So if you merge these two, what you get is something like this. Right, this is 1 and this is a partial negative charge here. Correct, this is the structure. Now, if the electron withdrawing group, if you see, if there is the group which withdraws electron, that will do what? That will increase the acidic strength. Correct. And the one which gives electron will decrease the acidic strength. See, why I am telling is, if it has a negative charge, if there is someone to pull electron from here, right, the negative charge will become less. Right, so we have seen that this is a product. Please understand, this is a product. This is not a reactant I'm talking about. So more stable is this compound, more acidic is the carboxylic acid I'm talking about. So since there is a negative charge here, if I have someone to attract or to take out the extra electrons, because the neutral compounds are more stable, you know that, right? So if somebody, and there should not be one charge center for a compound to be stable. So if there is someone who can take out the electron or take some electron from these carbon or this oxygen, the compound will be more stable, right? So if you have electron withdrawing group, that will electron withdrawing group will be more acidic. Why? As RCO minus will be more stable. Hope you understand this. See, if RCO minus is the product, it has to be more stable for this to be more acidic, because if it is more stable, you will form more of these. That means this is more acidic. And RCO minus, if you see, it's something like this resonating structure. So if this has a negative charge, there is somebody to take out the extra electrons from this side, it will become more stable. So electron withdrawing group will make it more acidic, right? Because it will make this RCO minus more stable. The RCOH will be more acidic. And the reverse is true for electron releasing group. If there is someone who is releasing electron, it will be releasing a stable electron. So this product is unstable. This is stable. This will become unstable. Right? Because already there is a negative charge here, and this R or whatever electron releasing group is giving electrons. So in that case, this will become unstable. Correct? This is electron releasing group. So if this is unstable, it is not that acidic. And this is electron withdrawing group. Just understand that we are thinking only from the product perspective. The product, we have to make it more stable. It has a negative charge, so somebody is there who can pull the extra negative charge and distribute this negative charge so that the whole product becomes more stable. Correct? So with this, if you see, this is the effect actually. So this CF3 is the one which has electron withdrawing group, because fluorine withdraws electron, right? This is maximum acidic. And then is the CCl3, and the worst is this guys, this alkyl groups. Alkyl groups gives electron, it gives electron, but these groups takes electron, takes electron, takes electrons. The more fluorines, the more chlorines, the more is acidic. Here if you see, it's all alkyl group. If you see, the benzene is a little better, right? But benzene is here with the alkyl group. This is a normal benzene, still better. Similarly, you can just find nitro group is still electron withdrawing group, still better. So with this, you can just, if you are given 5 or 6 compounds, then you can order it. Which one is more acidic, right? The one which has electron withdrawing group attached to it is more acidic. correct? So if you see the acidity, CF3 is maximum electron withdrawing group, and then I think it's CCl3, and maybe nitro group is also electron withdrawing group. CN is also electron withdrawing group, right? Fluorine is also electron withdrawing group. Chlorine also electron withdrawing group. Bromine is also electron withdrawing group. Iodine also electron withdrawing group. Phenol is also electron withdrawing group, and this R is electron releasing group. This is the strength. This is the maximum electron withdrawing group. So you have to remember the order of electron withdrawing group, and then we can easily find the strength of a carboxylic acid. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.